Hello, and welcome to the virtual Kansas City SQL Server user group. We're thinking about renaming that since we are so much more now, but welcome to our Lunch and Learn Power BI and Machine Learning edition. Thanks everyone for joining. Today we have David Yitzhak presenting Power BI, Machine Learning, and OpenAI, the Fast Track and Complete Guide. I feel like we're in one of those things, two things that go great together, ads like chocolate and peanut butter or sweet and salty. I'm glad it's lunchtime here. For our US folks, this may be a lunch and learn, but don't feel left out if you are joining us from somewhere else. Feel free to eat, snack, or just sit back and relax and learn along with us. For the audience, this session is recorded and monitored by the powers that be and will be uploaded to our YouTube channel. Questions will be answered at the end, time allowing, and David has graciously put some information in the Meetup event if you have additional questions after the event. And as usual with our Lunch and Learn, we jump right in. And with that, I'm going to let you take it away, David.
Okay. Share the screen. And I start. Everybody can see? Yeah. Okay. Welcome everybody to Power BI Machine Learning in OpenAI, the fast track and a complete guide. I will rush very fast, but I promise you, I want you to show you general picture of this, show you from the starting point how to do AI machine learning project. And all the the demo will be available at the site. I will give you a link. I already put another lecture of mine at the site. So my name is David Yitzhak. I have a BSc, I have 3 degrees, BS Information System, 2 second degrees. I'm a research associate, lecture all over the world. Have over 24 years of experience with SQL Server, Oracle Science, Postgres, Power BI, application infrastructure DBA. So this is the demo directory. I'll give you a link. And this is what we have in this demo directory. This is the link to the demo. I'll post it in the site. You have all this. You can practice after you will see this lecture. So, agenda. First session, we'll talk about how we build the data model, load the data, and explore it. Okay. Assumption: we will not use Power BI, no compiler, no data flow. We will use only our Power BI desktop, SQL Server, or Postgres, and we'll do it with Power BI desktop and SQL Server. So the first section is requirement data model load explore. The second section is how to prepare data with Power Query. The third is build a semantic model. The fourth is how to find feature for our machine learning with R, Python, and Power BI and visuals. So this is about me. You can see last lecture was in Data TLV about essential concept of vector database for DB and developer. I already put a link at the site for you for this lecture, and I have a lot of lecture all over the world in SQL Server. You can see Oracle, Power BI, etc., etc. So let's start. First, so as I said, we have a demo file. In demo file, let's look here. You can see it here. This is the lecture of our demo, part 1, part 2, part 3, part 4, and this is the data file. Okay, I already opened the last Power BI, the part 4, because I don't want to open all the time and I want to rush. So we in our Power BI, we upload the data file and we can start the demo. So first we have to install Power BI Desktop. It's very easy. You go to this link and install Power BI Desktop. So this is how you install Power BI Desktop. A minute. This is how you install the Power BI Desktop. Okay. And what is in FA Watchtrack database? What is FA Watchtrack database? You can see it here. This is This is a database of the FAA in USA, which talk about the accident between airports and birds. So this is the database. You can search database, see here, and you can download the material. The material is access files, which all the accident till now, and metadata Excel file. You can download it here. So after you download here, we will use it for our model. So how to explore FAA White report data? So after we download it, we have access files. You can see it here, the access files. Okay, and you have a metadata with Excel file. You can see it here. Okay. So if you open Power BI Desktop, we go to get data, and then we go to the access database, and then we choose strike reports table, and we upload it to our Power BI Desktop. Then we can do transform data. You can see it here, and we can see how the data is, the statistics about the data. So if you go here, you can see that if we are going here, this is the strike report table. You can see it here, and this is the data which we uploaded from the access files. So we have incident date, airport, the time of the day, airport ID, airport name, longitude, and all description about the accident. So you can see it here. Okay, so you can see that we have field which name index NR. If you look at index R, you can see that we don't have no empty value, none error in the column statistics. So if you look down here, you see that we have listing 1000 and unique 1000. We have time of the day. We can see that we have only 5 distinct values and about 15 which are blank. So if I go here, you go here, home, home, just a minute, some data. So this is a quick way after you upload the data from the access file, Power BI Desktop, to see how the data, the statistic about the data. So you go here, you can see all the statistics about the data. So you can go here and you can see how if the data is valid, not valid, how much, how if there are errors and empty values. So you see that today we have 5 distinct values, and you can see it here. And we have the README XLS file. The README XLS files contain the column name, have sheets column name, and contain names and description about column in Wi-Fi access DB. It's metadata file. So what it contains: date and time field, event, aircraft, estimate of the damage due to the strike, Wi-Fi strike report. So if you go to the Excel file, you can see it here. So this is the data, the metadata. So this is column name and description in the access file. Sorry. So you can see it here. So after we will upload the Excel file into our Power BI. So this is the Excel. We upload it. And you can see we upload it. And we'll choose aircraft type, engine code, engine position. We choose only this for the Power BI. So if you go to the Power BI, you can see that we have here these fields. So, and you can see distribution of the data. For example, aircraft type, you can see A, B, C, D, and if it is airplane, helicopter, glider, etc., etc. We go to engine code, and you can see the engine code here. You can see that we have engine code, we have null, we have also engine code here, and here's the data. After we upload it, we'll do close and apply. Okay. So what is our goal of the project? The goal of the project is to create an analytical report to view the trend over time of number of incidents between airplane. We choose airplane because airplane is more popular location of the incident A and detail such as type of the aircraft and what species. The predicted damage when the strike is reported make prediction whether there'll be a cost associated with this damage. Predict the size. What strike is reported make prediction about the size of the wildfire that struck the report. maybe it's more than one bird, predicted which ate this was the strike between the airplane and the bird. So we have strike reports, okay, and we have the Excel file with engine code, aircraft type, and engine position. So if you look at our data, okay, again, this is the final report because I don't want to open but you can see that you can see it here. This is the fact table, and this is the dimension table, okay? So you have the date, the strike report fact, you have the engine code, engine position, aircraft type, and the date dimension. So this is after we upload it, the file, okay? So if you are using ML, we want to do predictions, and each of these is features which will be input to our model. Okay, so what there are still approaches to take in Power BI using AI models. One is to flatten on the model. So flattering the data, it's when we take the engine code, engine position, aircraft type, strike report, and make it one big table. So what is the pro and the cost? Pro, it's simplicity. You don't have to do joins. You can use columnar indexes to compress the data. You don't have a rational model for business users. It's commonly used for data scientists. Data scientists work with flat file, but the cons, insufficient storage, of course, limited queries, less flexibility, complex logical queries can be efficient because we are talking with flat files. And of course, you can take the aircraft type, strike report, engine code, engine position, and make it star schema. So strike report is here, and you have the aircraft type, location, species, engine code, engine position. So this is the main fact table. This is the aircraft type. This is the location, the species, engine code, engine positions. So this is star schema. What is the pro and the cons? Pro, business logic, use star schema. Okay. We have a balance of minimal data with application and efficient queries. Why? Because this is how we build data warehouse with fact table and dimensions. Usually expandable solution can grow. This is recommended standard for BI data models, but that is the cons. With modern tools, the benefit of reducing data duplication are less impactful. Okay, complicated ETL because we have table with connections. We have machine learning model are usually trained with a flat table, not with star schema. And they don't always scale well. Very large data volumes. Why? Because we have connection between the table and we have to do a complicated ETL. So we have the hybrid design. What is the hybrid design? The hybrid design combines the feature of flattened design and a star schema. So in our case, the strike report. This is strike report. You can see this is the column of strike reports. Okay. Aircraft fact table. You can see it here. This is a fact table. Okay. A strike report is a table with a few than less 3,000 rows and less than 100 columns. So only 2 columns, the 2 columns in which the user input remarks and comments. This, you can see this. Okay, this is the only big column. So you can see it here. So we can use the hybrid design. So what is the hybrid design? The hybrid design means that we will leave the strike reports. Okay, in our case, the different data we don't have. There is no difference data storage between flatten and star schema. So we can use it's minimal. So we can use the hybrid design because we are talking about 3,000 rows. Okay. So designing data model without performance concerns data source of millions of rows on other columns. So we don't have millions of rows. So column on the left transaction table will be used as categories testicles called dimension. So what it means here? We leave engine code, engine position, aircraft type, and maybe we leave dimension table of date, but in strike report, we will leave what it's called the generated dimensions. In strike report, which is a fact table, we will leave the remarks, we leave the fields of comments and remarks. It's okay because we're talking about big storage. So the pro, rapid prototyping, less lodging data transform layers, flexible design. but the cons less performance than star schema. Additional logic complexity for user versus the big flat table. Still need to be flattened data for machine learning. Not perfect for either VI or, but it's common as including star schema and flat file. So again, this is the hybrid approach. In hybrid approach, in the fact table, we put description columns, that's the dimensions. So let's run fast. So we can use other sources for our model. We want to model, so we can so additional data sources, database table for aggregations. So if you want to use it, they're easy. Time-based table for aggregation hour, it's easy. Date of the flight that didn't have wildfire strike. It's difficult to use this source of data. Weather data that map to data and date of the wildfire strike. It's difficult. Data about wildfire species, weight, range, habits, range, it's difficult. So this is other sources we can join to our data in order to build a machine learning model. So we want to add timetable to solution. So if you go to time column, okay, if you go to time column here, you can see that we cannot use the time column. Why? Because the time column, 25% of the entries are empty. So it can be a candidate for date column, okay? So, by the way, if you go here, just a minute. If you go here, you can see it here. If you go here, you can see data. Go here, and you can see the statistics of this column, incident, date, etc., 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 etc. But you can create, but more interesting, I want to show you that what's more interesting, but if you go here, you can create very fast DAX query. So if we go to aircraft start report fact, and we go to, for example, to incident date, and here you can create a quick query. You can see it here. You can quick DAX query. So here, quick queries show that approach show column statistics, for example, and here you can run it. You can see, and you run it. You get the DAX query, and you can run it, and you can see the sin value, null count, mail, etc. And the DAX query is created on the fly. So you can see it here. So here you can see distribution of all the columns. So what is candidate to be the date column is incident date. Why? Because incident date is 100 values, 0 error, and it's not empty. So this could be our date column. So this is how data scientist or data engineer check the data. Okay. So if you go here and go to quick queries and show statistics DAX query, you can see also the distributions. So incident date is fully populated with date value, and you can see it in the DAX query. This is DAX query which was created in Power BI desktop on the fly. You can see it here. So this is our final model: strike reports, aircraft strike, engine code, engine position, and this is date which we'll be taking from with incident date. Incident date will use our date table column. So, so how do we build? What is approach of what is consideration for ML? We'll create a table of data to train the machine training model. Okay, treat each column as feature. Each column is a feature for the algorithm. Feature, input, attribute. Okay, and then we'll use to train the model for predictions. For example, if you want to use create ML algorithm that predicts whether something is an insect, we have features. Okay, so what is the phases? This is the raw data. Okay, we will create data. We'll do a data exploration. Initial data collection Power Desktop will see it. We'll make analytic report. We'll do a feature discovery. We'll create data set in Power Query. Then move the training data set to Power Data Flow, and then train, test, and deploy. So if you go here, you can see this is the raw data. We'll explore the data, and then we will we will do, here is the data set for the cache data in Power BI, and here is the feature, the data we will use for our training data. Okay, so we have in the Power BI 3 different predictive model type, binary predictions, which mean predict yes or no. General classification, predict whether the outcome is A, B, C, D, etc. So this is general classification. Regression, model will predict a numeric value. Okay, for example, it will predict the cost of an event based on similar past events. So the project should give us analytic report to explore and identify the right data for Power BI machine learning model to predict the damage, what damage will result in the wildfire track. So this is a binary model, which means yes or no, may damage or not. Predict the size of the wildfire track that struck the aircraft. So the damage cause, damage location 8, etc., etc. Output with multiple values, large, medium, and small. So this is classification model. We want to predict the size, whether it's large, medium, and size. Okay. Predict the age at which the wildfire track will happen. This is a numeric value which represents the age about the ground where the accident happened. So we'll use regression model. So again, predict damage, binary, predict size. This is general classification, and predict the age. So, so again, this is the second part. The second part goes with the second part of the demo. So I do it very fast. We upload it. Okay, this is, you can use the PBIT file, or you can use X file, or you can use template file, which upload the two demo file, which is the two data file, which is access and XLS file. So here up, you upload it. Okay, now this is step one. So we run very fast. First step is to grow the raw data. What is the raw data? So we go here. This is the raw data. This is the data as we upload it from the access file. This is, and the Excel file. You can see it here. This is the raw data. Strike report from the access file. Aircraft type, engine code. You can see it here. You can see the data. It's not clear. Engine position. This is from the Excel file. So this is the raw data. Okay. So we create a group which name raw data. And here we put our strike report, aircraft type, etc. We disable enable load. Why? Because we don't want to upload raw data to the Power BI service. Why? Because it's raw data. It will consume resources. We don't need to consume resources. So we want to evaluate the stack report data. So we want to evaluate date and time dimension column in stack report. This is fact table. We want to evaluate geographical and location columns. We want to evaluate aircraft and operator descriptions. We want to evaluate the species and animal columns in stack reports. We want to evaluate the weather, flight detail, and stack damage. So from the fact table, we want to take all this data. Okay. So aircraft type table, we have aircraft type table. We have the aircraft code is unique in table. We have two values, which is AC class in stack report. AC class is foreign code to aircraft type table. So it will be more clear. If you can see it here, you can see that we have the aircraft type code, which map to AC class in the fact table. You can see it here. So this is how you look at your data. Okay. Engine code use both manufacturer code and model code. Okay. They are mapped to AMA and AMO columns in stack reports. Okay. So this is, you look at the data, you see that this in engine code in dimension table is mapped to this column in the fact table. And we have engine pose 1, engine pose 2, etc. This is mapped to engine position table. So again, this is the raw data, and the raw data you have and we have the date table. So the date table in date table, we don't have currently a date table. We have to create it. So just to show you, Okay. So we have, this is the fact table. You can see it here. This is the engine type, which has aircraft code, which is mapped to the fact table. You have to figure out which columns are mapped to which column. This is the engine code. You can see it here. Very messy. You can see it here. We have engine positions. And if you go to Strike Report, to the raw data, you can see that this is the column which are mapped to these tables. Okay. Let's start first. So the first, we have to, as data engineer, data scientist, we have to pass on each column name, the name, and we have to do a criteria, the column name, the name of the column is Strike Report table. Initial data type, what is the data type? We have to detect in Microsoft Access file or auto-detect in Power BI. So after upload the data, we have data type. So we have to check if the data type is correct. Note, your note about each column. Maybe to keep the column of the row. Maybe it's not relevant. New data type, what should be data be for the new curated version of the table? Key is the foreign key column. You can see we find foreign key column between the dimension table and the main fact table. Reporting name, which should change the column to a friendly reporting name. So you can see that we have, let's run very fast about example. Incident date. So initial data type is date time. Okay. Note, this is a note. Keep, yes. New data type, date, yes. Incident date. Incident months, no. Why? Because incident type is included in incident date. So you don't have to keep it. Okay, incident year, the same. Time, no, this column is missing data, so we will not use it. Time of the day, the column is more frequently populated. Okay, and etc. etc. So you have also airport ID, airport state, and this is how we pass on data, and we decide whether what is initial data type, no, skip, your data type, next. It's a hard work, but it's needed in the first say. Copilot, etc. will not do this work for you. You have to do it your by own. Okay. So if we run very fast, and now we want to build a date column. So a data column. And how do we build it? First, we'll create a group which is created grouped reporting queries. This is created group queries, and then we go to our raw data and make a reference for the Strike aircraft engine code engine in created report. So if you look here to demonstrate you, so if you go here, you can see that this is created report and this is the raw data, and you can make a reference. And this is the reference. The reference is a pointer to original data, but here we can change the original data. So I make a reference to Strike report, to aircraft type, which is character info, engine code, which is code info, engine position, which is engine position info, and this is the date info. How did you create this date info? So this is that. So in the created data, we'll keep only the column that we need and we get rid of unnecessary column. You can see, for example, an example for a column we didn't use for the created report, which is really in the reported data. Incident months, etc., etc. Okay. And this is the data type changes Strike report data. See it here. Okay. So this is our created reporting queries. This is the raw data after we move unnecessary columns and updated the column data type. So this is the column name change for clarity. We change also the column name. For example, incident name, we change the report name to incident name in created report. Time of the day, etc., in the created report. And this is all the list. Okay. Now, so this is created report queries, and this is things. You can see this. We use the created report queries for the analytic data. So you can see aircraft type, engine code, we did the reference, and we moved them to the created report queries, and here we did all the changes. And I want to show you what we do in aircraft type. So in aircraft type, we have to move to unselect on the null value and use the first row of header. Why? Because in the Excel file, the first row was aircraft code, aircraft specification, there was null. So what we do here, we go here and say that use first row as an header and unselect null. And after we did this, you can see that we have aircraft type info table, which is a range A, B, C, D, and this is the descriptions. And the first column is descriptions, aircraft specifications. And we should do it for engine positions. For engine position, look how it's look. Again, use first row header, and again, unselect null. Okay, so this is the engine code info query. And we remove unnecessary column for 5 and 6. And also for manufacturer code. For manufacturer, if you look at manufacturer code, to show you, open the Excel file. It's very interesting. Engine code, engine position, engine position, engine code. You can see how it's go. Manufacturer code is this is all this is manufacturer code, and you see the model code, and you see that all this, for example, if it's 01, all this is manufacturer code, all this is manufacturer 2 and 4. So how do you treat it in Power BI? So what you do, you go here and highlight the manufacturer and engine manufacturer code column, right click and select fill down and unselect null. And you can see that this was in the Excel file. And now all this was filled with the manufacturer code of 01. And here, engine manufacturer with Ellison. So, and unselect now. So if you go to manufacturer code here, in it, so if you go here, sorry. So if you go to here, you can see that now it's for the range, because you can see that you have the manufacturer code, the model code, and the engine manufacturer, and no null value. You can see it here. Okay. And now we'll build our date table. From one option is to build it from CSV file. So you can take it to CSV file and build your date table. But the most simple option is create a calendar table using Power Query and GPT. So you go to GPT and tell him, prompt, access a Power Query expert and help me to write my following all code. Sure, GPT said. And I tell him, in my Power BI report, create a calendar table, blah, 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 from 1/1/22 to do, and I need the following column, date, name, short, etc., etc. And I do not know DAX because I'm DBA, but GPT will create your code, and we'll code also with code explanation. So after I create with code, we'll create a blank query here, paste the code here. This is the query, including remarks and description. And voila, I have a dim date table created by GPT-4. What is interesting that we will also index it, because I'm telling, if you look here, I'm telling date show, blah, 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 date 9, year, quarter. Use the following, add a blank line after each step. All column have a defined data type, a blank line, a summary overview, and I need the following column, and I'll call, and so this will be, this code will create a dim date table. You can see it here. Okay. So let's talk about the semantic model. Semantic model, very, very important. So This is the part 3 of the demo file. You can open the PBIX file, or you can build a semantic model using PBIT file and upload the Excel file and the access file. So what we have here, we want to build a relation between table space, between the tables. So we have the table. Okay, we have the table, dating. We have the aircraft type info, which is aircraft code machined with aircraft class code on Slack report table. You can see it here. We have the engine code info, okay, which is contain manufacturer code and model code, are compound to key machine up with AMO from Slack report. So if you look here, you have engine code in, we have manufacturer code and model code. This is foreign key to AMA and AMO in Slack report fact. And what we have in Slack report fact, engine position, which is engine position code 1, 2, 3, 4. And we want to map it to engine position dimension, which contains only one column, which is mapped to these 4 columns. You can see it here, which talk about the position of the engine. So you can see that we have that table. We use that info. We go to the table, that info, date, Slack report, incident tape. So what we see that we go to our fact table. We found that incident tape is valid, 100%, no error, it's full. And we will map it with foreign key to our date column. So you can see it here. So this is the date column contain a valid primary key, incident date. So it's okay to use it. Again, this is how you ask a data engineer or data scientist, map the data. AI cannot do it, Copilot cannot do it. So the column are ready for relationship in dataset. You can see date and incident date. And now we want to map aircraft code in Slack report and aircraft class code. So on the aircraft type info table column, there is aircraft code. Each row contains unique letters that identify the row. Aircraft classification column provide description of that of the aircraft. So what we do here, we map aircraft class to aircraft class code in Slack report. You can see it here. You can see it here. Okay. And also what we do, we will replace all the empty null value with the word blank in Slack report. Aircraft class code, because why? ML model design don't know how to work with null value, blank value. So because ML model design and reflection register. So what we do here, we'll do these tricks. We'll go and we'll see that we go to Slack. We go here, okay. We handle this how instead of using a blank value or null value, we will put our value. So right-click on aircraft class code and select replace value, and then type in null value to blank and replace with blank. So blank, blank, null, null. Okay, you can see it here. So add 2 new rows to the aircraft type info query, one for the null text and one for the blank value that shows the as null. Replace the value in the Slack report query. So you can see it here. Add 2 new rows to the aircraft type info query, one for the null text and one for the blank value that show up null. Replace the blank value in the Slack report query. So again, we replace the null value and empty value with blank, blank, null, null. Why? ML model do not know how to work with empty values. Engine code info. In engine code info, we'll add a new row to engine code info table for unmatched value. So in this case, we'll use incomplete or missing. So you can see it. I go here. Why? Because there are some values which are missing. So I will go to engine code engine code info and use missing and incomplete. So all these tricks are for the machine learning model who cannot handle empty value or null value. And I go to engine code info, and here on the ribbon query, select enter data, engine code info, edit data, and I will add manufacturer code and model code, engine manufacturer and engine model. And you can see it here. And I create this table, manufacturer code, model code, engine manufacturer, engine model. You can see incomplete, missing, incomplete, missing. And then I will add this to the engine code info here. Okay. So if you go here, if I go here, I want to show you. So you can see that this is aircraft type edit data, which is blank, null, null. Engine code edit data, incomplete, incomplete, complete. Engine position edit data, blank, null, blank, null. And now, if I go to aircraft type info, you can see that I took this and append this to aircraft type info with blank, blank, null, null. And now there is no blank or null value. Aircraft edge code edit data, you see incomplete, missing, complete, incomplete, missing. And I go to engine code info. Okay. You can see incomplete, missing, incomplete, missing, incomplete, because I append this to engine code info. If I go to engine position edit data, you see black, black, null, null. So engine position, so you go black, black, null, null. Again, very important. Model in machine learning model cannot handle black value, null value, empty value. So I have to replace all the value with the word black, black, null, null. And okay, so how do you do it? This is how we do it. And this is all the face. And just a minute. So this is how we do it. So we want to get a connection. So if we go to engine position info, we have inside for engine position code 1, engine position 2, engine position 3, and we do the same trick with null and black, black. You see it here. This map to engine position info table. So you can see it here. Engine position map to 4 tables. And in step 3, so this is how we handle NP value and null values. Now we want to build this, our Power BI dataset, which is Sketch. So we have so because if you look here, this is a cache data. We have to go to the created dataset tables here, and we have to do enable load and include report and refresh. Why? Because this is take place in the Power BI service. You can see it here. Okay. So do the following step to build your Power BI dataset. Important, process the one track for queries, create relationship between the fact, dimension, and clip out the metadata and data settings. So let's do it. Okay. So we go here and we create a connection. So let's show you more simple here. Okay. So if you go to the relationships, it's all the relation, you can see that we have created a relation between dating table here. If you go here, you can see that incident tag is connected to date column. Okay. If you go here, you can see that we have connection between aircraft type deep and aircraft class here. If you go here, and if you go here, you can see that we between engine position, location of the engine, you can see if you go here, properties, you can see that engine position 1, 3, and 4 is mapped to engine position in the dimension table. So if you go here, okay, you can see that this is the connection between the tables. We go here and create the connection, create the relationship. We create the relationships, and we here we sign make the relationship active. You can see it here. So create a relationship between strike report and affect the table. Then and filter direction are set to many to one and single. So this is the connections. We will repeat the process for all these connections. So let's see it here. And we build our connections. So create relation between the fact and dimension table. So you can see it. So if you go here, that strike report facts, aircraft type dim, many to one, strike report fact, engine code info key, and it's mapped to engine code dim, engine code info key, many to one, etc., etc. And you can see how we build the connection here. Again, we upload it. There were no connection. We create the connections. So you can see that how we can add the connection here. So this is the complete relationships. You can see it here. And now we want to clean the metadata and adjust settings. So we want to hide unnecessary columns, foreign key on surrogate parameter key. We want to adjust the summarize of that category and adjust setting for dating. So this is the list we have to do. This is the list, what we do for example, we want to click here. If you go here, so if you go here, let's go to here, sorry. So this is the raw data. This is copy of the raw data and corrected reporting. This is the corrected dropper statuses, which will do enable upload. And here we did, this is again reference of the corrected reporting queries. And here we did all what is written here by necessary column in the report. And also adjust summarization, data category, format and sort and setting, summarizations, date category, summarization date category, and sort by. So you can see, for example, strike report facts, don't report, summarize, latitude, sort by, etc., etc. So this is the long table which tells how do you handle data. And this is, you can see it here. Okay. You can see it here. It just summarize that category. And also we go to our dating table and go here to tool table, make a date, make it as a date table calendar, dating. And so if you go here, you can see that this is our data set. This data set will be uploaded to the Power BI. Therefore, the raw data is not upload. Upload is disabled. Also created report set, but this data is enable upload. This will be cached to the Power BI service. And now we want to make measures. Okay, we want to work to sorry. Want to make measures. So we'll do measures for incidents. Incident count of strike reports. Now calculate the count of the total incident. We want to calculate the average speed, average age of average age, total cost of repair. So this is another measure, sum cost of repair, average cost of repair, sum cost of repair. Incident risk cost. So look here, calculate incident, filter, strike report, cost of repair greater than 0. Percentage risk cost. So divide incident risk cost this by incident. So how do you do it? It's very, very easy. You go here to quick measure and you create the measure here. So if I show you here, here. So if you go to type of activity, you can see that you have the average age. You can see it here. Cost strike per average, you can see it here. Cost per strike median, etc., etc. So this is the measure you have incident count also incident. So this is how we make it. Summary. So what we did here, we designed the key table for Power BI dataset. Created in Power BI dataset and added the measure to the Power BI dataset. We know we have the basic foundation of analytic and building analytic report. So now we can build analytic reports. So let's go. forward. How do you define feature with R and Python visuals? So this is the iterative process. You see that we build our Power BI dataset, which is cached. This is the raw data. This is the analytic data, which is not cached. This is the raw data. We will explore this data in order to create feature, to find the feature which will be the input to our machine training data. This is iterative reports. Why? Because the data all the time change. So you can use Azure services, but I prefer to use R and Python visuals within Power BI. Why? R and Python is very popular. So this is the iterative process of discovery. Explore data set in Power BI, add feature to ML training. So let's see. So how do you explore association between variables? So two variables are associated if the values are related to one another. So correlation between numeric value, you can see it here. We have to, if there is correlation, we have to plot the variables. So here we have two variables. We can see the correlation between the values. So you can see that we have positive direction, negative direction, no defined directions, and no defined increasing and decreasing. So this is how we explore association between variables. Why? We want to find all the variables of the incident to find whether what will cause the incident. So there are many possible forms, but the most common are linear, you can see it linear, and non-linear curve. So what is co-pilot in R? Let's see example. In R, data frame is like a table. Assume that we have vector X, 1, 2, 3, 4, 5, Y, Z. So if you tell in R, it's very, very simple. Data frame which is stable, you put 3 vectors. Okay, and tell him correlate data set. What we'll get here is this. Let's explore it. X and Y have perfect negative correlation. Why? Because if you look at X, you have 1, 5, 2, 4, 3, 3, 4, 2, 1. X is increase while Y is decrease. So if you look here, you see that X and Y have a perfect negative of -1. X and Z have perfect positive correlation. Why? Because X is increasing 1, 2, 3, 4, 5, and Z is also increase 2, 4, 6, 8. You can see it here. So therefore, we have here X and Z. We will have 1. Y and Z, you can see X and Z, 1. Y and Z also have perfect negative correlation because Y increase while Z decrease. So how do you create R correlation in Power BI? So you have to enable R. I don't talk about it install now. It's very simple, but you have to enable R, and you have to convert true false column to integer columns. What's the meaning here? Because R cannot work with 2 and 4 columns, you have to take the columns and to convert them to 1 and 0, represent false or true. Okay, otherwise, I will tell you I cannot display this because this is not a numeric value. You can see it here. So how do you do it? You convert all the 2 columns to an integer column where 1 represents true and 0 represents false. So you can see this is all the columns. Slack engine, damage engine, incident engine, Slack, etc., etc. Take this. And then after you do it, you take ask visual and drag it to your board. And then set the filter on page on to match predict damage with, you can see it here on the page. We select only the airplane and airplane and year filter to be greater than equal to 2004. You can see it here. And then we use to add the integer indicate damage to our values. So this is the ask editor. And now you write only this simple code. Require coplot which mean load the coplot library call load mean load the library. M-core dataset mean take all these variables and create a correlation between them. And core plot M mean plot it. And this is the color, etc., etc. And you get this. So you can see this is the code. This is all the variable which we copy and make it to int. And this is, so let's see it here. So if you go here, go to our visuals, you can see it here. So if I stand here, you can see the code, very, very simple code. And this code uses these values of integer, which true or false, which make integer. So what does graph tell us? So very, very little effort, we make this. So what does graph tell us? So you can see it here. You can see it here. Our correlation plot will go for the integer. So the correlation plot displays circle and increase in size. So larger circle indicate stronger correlation, closer to 1 or -1. Smaller circle mean weaker correlation, closer to 0. Color, blue indicate positive correlation, white present no significant correlation, red indicate negative correlation. The diagonal of the correlation plot will always perfect correlation. Why? Because it's between the same parameter. So if you look at these graphs, you can find a correlation between parameters. You can see it here, and here, and here, and here. Okay. And we will find the features, the variable which have correlations. So you can see that in just other, have correlations predict damage, predict size, predict age. And this is the table we created from this. And we'll select the columns related to ML query. So if you look here, okay, here we have ML queries. So predict damage. Here we added all the variable which will predict damage, predict size. Okay. Now we're doing Python. So in Python, we use Instagram. So how do you install Python on Power BI? You can look at this link. But what is more interesting, we want to find the correlation between age and speed. So age and speed integer column also contain empty value. Empty value with numeric value of data can be tricky because we don't know whether it's 0 or unknown. So for the report page, we will filter the empty values for each visualization. So we'll filter the empty queries. And now select the Python script. Set the filter page to predict damage. You can see it here. Predict damage. And to filter airplane and year filter greater than equal to 224. And we'll do this. This is the code, simple very code. Import mean methodology pilot as PLT mean import this library, call it with nickname PLT. Data plot kind history y speed, investigate y. X label is speed, y label is incident, and this is the title of the graph. So if you go look here, you can see histogram for the speed and the number of accident. Now we want to identify the new feature speed for incident without damage. So it's very simple. Copy the previous code and now import totally. Copy and paste visual to code, rename data to speed instead you can see it without damage. And change the incident damage filter on the second Python example visual to false. You can see it here. And filter the patch for speed less than 700 and create 700 and create compatible Instagram. And you can see it here. So if we go here and look here, it's very, very simple, very easy with Python and R. If we go to Python, you can see it here. So example, 8 with damage. So we go here, you can see that incident damage is true. speed is not black, and we go here, a minute, ASCII editor, and you can see the code. The code is very simple. Kind histogram, Y speed, X level speed, P level incident, P level incident, title 84 with damage, and then show. And then it will show us the correlation between the speed and incident with damage. If you go without damage here, okay, you can see that this is without damage. So incident damage is false, and this is the same guy without damage. If you go here, for example, here we explore the correlation between 8 and incident. You can see it here. So this is histogram for 8 and incident. So you can see it here. So this is our graph. So we have paternization, avelizations. Okay. And what is interesting, that I use this parameter for our ML queries, predict damage. And 2 minutes, I want to show you very fascinating things. If you look at it now, if you look at strike report fact table, I told you that we have 2 description columns. Remarks and comments, which the user put inside the text. But how can I explore this? If you want to use Azure AI, you can use it. But there is a more simple way. Why? Because if you go here, a minute. If you go here in SQL Server 25 or in Progress, there is a support in vector search. What is vector search? Vector search, I go very, very fast. Okay, very quickly. It means take all your data, which can be image, GIF, text, words, etc. Sometimes you have to make it to chunks and use your model and make it into embedding, which is vector, and put it in your database. Okay. And now you can do a prompt. The prompt will go to the database and do a vector search for find similar objects, and go also to your AI model and will combine this data. Why it's so important? Because in your data, you can put real-time data of your data model. I have a new language about this. So let's see example. So here you go, you can create, you can see that I can go to Azure AI, whatever machine learning, in this example, I use the AI community model and put, you can see what I put here. I put, in this example, I can put text and this generate a vector. Okay. And then I can do a vector search for similarity. But let's see it here. I can do it also in Azure ML, because in Azure, I can get embedding for OpenAI for Azure SQL. I create an endpoint, it's very fast, create an endpoint, and I can use procedure to call to this Azure AI service to create all the time. I have new data to create vector from this data. Again, this data can be anything, image, voice, word, text. You can see it here. I run very fast. And this is the text embedded data I select for my text. You can see it here. And then I can find similarity search between a vector. So let's see something more. By the way, I can use trigger every time I put new data into my model and create new vector by calling. You have procedure in SQL Server which can call this AI model. So you can see it here. But let's see more example. For example, if I have two description column, an example, I have a table called food reviews. It can be the same table as in our example, about 3,000, 4,000 foods, product ID of different food with a score, summary, and a text. What I did, I took this summary and text and create a combined column, call to Azure and I each time I update this, and it will create a vector. See, this is a vector. Vector, take this and create this a vector. And now you can see how I call Azure OpenAI with store procedure, text embedding. I call the model, and this is the text, and this is the output of the vector. You can see it here. And now I can ask a question like, using search, for example, look for all, for example, for food which could contain gluten, dairy, and use the vector search, vector distance to find similar vector, and also to put, why it's called hybrid design, I can put also, for example, filters. So why it's so funny? Because now I can take the remarks and the comment which was put by the people who fulfill the details of the incident, create a vector, and then do combined search in my database, and then in other model and combine the result. So this is how the way we do a vector search on our comment and remark data, for example, to look for a bird, to look for similar accident, etc., etc. So you think I'm exactly on the time. Any questions?
We did have one question earlier. Let me pull it back up from Jan. He always has great questions for us. So he said, hi, David, could you share if it is still a good practice to use the Power BI dataset method if the performance of the trained model is not good and new data having more rows at the end, having to be used to getting a new trained model?
Okay, so good questions. I don't have exact answer for this, but as I can see, I don't always use this was a simple slow data set. I not always use Azure OpenAI models. Okay, and if you use Azure OpenAI models or Fabric, I guess you can give more resources to get the data be more trained fast. But I have another lecture which show you that you have to take several models, run the training data, and compare between them, between the exact of the result, and also between how fast the results. So there is no clear method for this. Okay, and if you look at my vector search present, there are also mistakes, so you have to be careful. So I don't have, but what I show you here, how you take the raw data and build it, prepare for the data model. And what I don't show you is another attitude is now it's new material because only now Microsoft enter vector search, which is also in Postgres, how to use vector search to investigate your data. By the way, if you use vector search, it's more fast than using Azure OpenAI because the data is embedded in your database. You don't have to call other models. So you can do vector similarity. You can embed your model inside. So there is no rules, but I show you a trick how you can do it fast. If you take all this to compile to Fabric, I don't think you will handle all this and take here to the final result here. You can see it here. This is the final result. You have to know your data. So what I do, I will upload a link, immediately link to the demo so you can train because it's a lot of material. It's a lot of material. It's not complicated, but you have to understand it. Also, know that you should use R visuals and Python. See the tricks there, you see, to find the correlations. And And what is the correct model? It's for another lecture. Open answer.
Yeah. Great call out too earlier when you did the call out on the null issue with machine learning. I find like a lot of people get tripped up on that, and lots of great data engineering validation information included. Really appreciate that. I'm always so glad.
By the way, they are wrong. So you can see example here. See.
Yeah,
show
so
you.
I'm always really glad when we record these sessions because I know
Okay.
I can go back and review them multiple times so I can
Here's
absorb
example where it's
everything.
wrong. Here's example where it's wrong, by the way. If you use the community model, by the way. I found it when it's wrong. Men and women, by the way. Okay.
Great job. Thank you so much, David, for joining us and presenting all this information for us today, and all the links. We always love it when speakers share their links with us so we can go back and kind of walk through it ourselves. So thank you very much for everything.
So I now upload the link to this demo, no problem. And also the link for the vector database, as you see. Okay.
Excellent.
So it's my pleasure.
I put your link for that you put in the event. I put it in the chat here. So people would be able to see it.
It's my pleasure. I hope it was not too fast, but it's not simple material.
A lot of information. I get
it. Sorry. Okay. Bye-bye.
Bye-bye. Thank you.
Have a nice evening, whatever. Bye.